Welcome to Neal on Fire, where we talk with innovators, scientists, and leaders who are changing the way we understand, prevent, and respond to wildfires. Today, I'm excited to be joined by Theodore Giannaros, senior researcher at the National Observatory of Athens, an expert on fire weather. Welcome to the podcast, Theodore.
Nice to meet you, Neil. Thank you very much for the invitation.
For those of you who are new to fire weather or fire meteorology, what exactly is your team focusing on, and how is fire weather different than our current understanding of weather, and where's the intersection between the two?
Okay, so to put it very simply, fire meteorology or fire weather meteorology is a branch of meteorology that focuses explicitly on how weather and climate interact with wildfires. And this is actually a two-way interaction. So basically, we study both how weather conditions determine the probability of having a wildfire ignition and this ignition growing into a large wildfire event. But at the same time, we also focus on how the fire itself interacts with the atmosphere, giving rise to what we call fire-atmosphere interactions and all this very extreme fire behavior we have been witnessing over the recent decades all across the globe.
So, how did fireweather.eu begin, and when was kind of the beginning point when you started to focus exclusively on fire weather?
We started focusing very explicitly on fire weather back in 2017 when our team had its first project on wildfires. It was a regional research project that involved countries like Greece, Bulgaria, and Cyprus. We lie in the southeastern Mediterranean, a hotspot of climate change and also a hotspot of a lot of ignitions, so wildfires was a problem that we wanted to focus on. Fireweather.eu grew out of another research project, the Flame project, and this is also the name of our research team. And it was the first project in Greece to establish the concepts of fire meteorology, fire atmosphere interactions, how weather and climate influence wildfire activity, because until then, I would say that weather and more generally meteorology, not only in Greece, but also across Europe, and this is in contrast to what we know about the States and Australia and Canada, all across Europe, weather was underrepresented when it came to wildfires. We were treated mostly as a static data source. Weather was supposed to only provide some input, and that's all. However, we saw that this is not really the case, especially under climate change. We have more and more extreme wildfires that very lively interact with the atmosphere and generate their own weather. And this is why we decided to establish fireweather.eu in order to address this very important gap.
So I understand you started the ROSETTA project, which focuses on pyroconvection risk across Europe and the most dangerous fire events. So for anyone listening to this, what can you tell us about the ROSETTA project and what you hope to accomplish with it?
Yeah, the ROSETTA project is our latest research kit. We are going to focus, as you already mentioned, on pyroconvection, which is the process through which wildfires interact with the atmosphere and start generating their own weather. Our focus is on Europe, and our goal is, for the first time, create first a catalog of verified pyroconvective wildfire events. This is one large unknown in research regarding pyroconvection. We don't actually know when and where these wildfire events happen. So the very first thing we are going to do is to try to go back in time, leverage satellite imagery and other auxiliary data sources to identify where and when these wildfire events happened. And when we have this catalog, we are going to link it with atmospheric conditions, the state of the atmosphere, weather conditions at the surface, weather conditions up in the air, and try to establish what are the thresholds that can be linked to the occurrence of pyroconvection. Ultimately, what we want is to understand how pyroconvection develops, if the conditions associated with pyroconvection have changed in the past, and finally, to see how these conditions are going to change in the future. And this is all because we believe that until now we have been underestimating how our future wildfires will be looking at. And this is mainly because we have been confined to the surface, looking only at surface weather indices, not looking at what the atmosphere actually does. And this is really, really important if we want to have a clear view of what awaits us in the future.
So I understand that ROSETTA is really the first of its kind in Europe, cataloging, as you pointed out, European pyroconvective events. Why has a resource like this not been in place until now?
Because I believe it is. I would say it's a cultural thing. As I mentioned earlier, not only in Greece but also across Europe, meteorology and meteorologists have been treated so far as an input data source. When it came to understanding the wildfires and how fires may interact with the atmosphere, we were only supposed to provide some input data, like, for example, what will the temperature tomorrow be, how strong will the winds will be, if we expect any changes in wind direction, and so on. This is all what meteorology was supposed to provide to wildfire management. However, in recent years, we are seeing a change in this issue, in the sense that we are getting more and more wildfires that very actively interact with the atmosphere. In Greece, we've seen this back in 2021 when we had an outbreak of pyroconvective wildfires. Pyroconvection was also observed in 2017 in the deadly wildfires in Portugal. And yeah, pretty much this is all. This is all why we decided to do this now, and why we believe it's also important. If you ask me why now, I believe that it's never too late to do this kind of work.
So, given the kind of research that you're putting together and the kind of models you're developing, how do you think that would have impacted the really tragic wildfire season that you had in 2021 and actually successive years as well? What do you hope will be different if the same conditions exist in the future?
I would say that what we aim at is at enhancing the readiness of our fire management practices in Greece and in Europe, and also with implications for wildfire management all across the globe. I don't believe in miracles. I know that there is no magic portion that we will develop and deliver to the world and say, here, the problem is solved. However, I believe that especially when we deal with this kind of wildfires, those that interact with the atmosphere, those that have those extreme fire atmosphere interactions, it is very important to try to understand them, understand the conditions that may lead to their occurrence, and therefore get this knowledge and translate it into practical tools that the practitioner, the firefighter, the fire manager could use in the field. This is our vision, because one important thing to say is that we're not doing this research just for the sake of the science. Of course, we are curious, are scientists. However, we would like to see our research applied at some point in the field.
So, given the changes in the climate that have given rise to more pyroconvection events like we're talking about, what trends do you see over the next several years that might be able to correlate the work that you're doing with kind of some of the changes we're seeing in the climate?
Well, truth is that we don't really know. And the reason that we don't know is that we have not been studying pyroconvection for a lot of years. It is a field that it is, I would say, pretty much in its infancy. The United States are leaders in studying pyroconvection, both from space and also from the ground. It is only, I would say, in the recent 1 or 2 decades that we have been specifically focusing on this particular field. So it is still unclear whether we are seeing an increase in pyroconvective activity, or it is simply an artifact of having more easy access to video footages, to photo footages, etc. However, one thing to consider is that given that until now we have been mostly relying on surface indices and surface weather conditions for assessing how a wildfire will behave and how a wildfire will evolve in space and time, I believe that we have underestimated actual fire danger and how our future wildfires might look. Consider, for example, that all the climate projections we have about future wildfire activity are based on well-established indices, like, for example, the Canadian Fire Weather Index, which whatsoever are based only on surface weather conditions. So we do not currently take into account how the future atmosphere will look in the 3D. And this is very important because under a warmer climate, with more heat waves, with more dry periods, you get a more unstable and deep boundary layer, as we call it, the very few kilometers of our atmosphere. And this boundary layer can support more effectively organized pyroconvection. And this is something that we have yet to study in detail to understand whether we are going to see an increase or what our future will be like more generally.
So wildfires are influenced by weather, but they also create their own weather systems. And what would you say are some misunderstandings that maybe the public or governmental agencies have about fire atmosphere interactions that lead to creating their own weather systems during a wildfire?
Yeah, this is a very important aspect of our present and future. I believe that we are at the point that we must make a clear distinction between what we would call the normal wildfires, the wildfires we have been getting more commonly in the past, and these are the wildfires that are spreading quasi-steady. And if we know topography, fuels, and surface weather conditions, we can more or less predict how they will spread and behave. But over recent years, we have been getting more wildfires that are belonging to the category of extreme wildfire events, and these are those events that couple with the atmosphere due to the enormous heat that the fires release and the structure of the atmosphere itself. They manage to couple together, and at that point, we're not talking anymore about the simple wildfire, but we're talking about a coupled fire atmosphere system where the fire defines the atmosphere, the modified atmosphere defines and feeds back to the fire, and so on. And this is something that I believe we have not paid too much attention. And this is something that, especially under the context of climate change, we need to focus on to get a better understanding.
Talk more about how the fire atmosphere coupling turns an ordinary wildfire into an extreme wildfire event.
So when we talk about pyroconvection and this coupling between the fire and the atmosphere, the first thing we need to say is that in principle, every wildfire could become a pyroconvective wildfire. And this happens because of one very simple notion. The heat that the fire releases warms the atmospheric air. The warmer air starts rising up, and this alone creates a circulation around the fire itself. However, under certain conditions, and these conditions involve, for instance, the very intense burning of the fuel. So the first thing we need is an abundance of fuels, very dry fuels that will burn very intensively. So the huge amounts of heat that are released through the burning process hit the air starts rising up, and depending on the structure of the atmosphere, if the atmosphere is unstable, favoring the upward movement of the air, we must get a very well-defined circulation where uh, creating a feedback loop. The rising air, you have cooler air rushing in to replace the rising warm parcels, and this creates the whole circulation. And under extreme conditions, these rising warmer parcels may result in creating these clouds that we call pyrocumulus, or at the very, very extremes, like events that we have witnessed in Australia during the Black Summer, or in the United States in California multiple times. You may end up with even storm-like clouds, which we call pyrocumulonimbus. And these below are found at the very end of the spectrum of pyroconvection.
So, what makes modeling fire related or fire generated clouds and events so difficult compared to normal weather system modeling?
The lack of data, I would say. This is what we currently lack. And in my view, this is where fire meteorology can provide a lot. We can draw, for example, from the paradigm of how meteorology works to address other extreme weather phenomena, like, for example, hurricanes or tornadoes. So the first thing we did in order to model hurricanes and tornadoes was to chase them, get the observations, go back to our labs, understand how these systems interact and act on the field, and then develop the models. When we talk about these coupled fire atmosphere systems, these pyroconvective wildfires, the truth is that we currently lack the detailed observations that would allow us to get a better understanding. Of course, this can be attributed to the difficulty of getting these observations. When we talk about an extreme wildfire, it's very difficult to be close to it and to really get real measurements from the fire environment. However, in the past decade, I would say, this is also gradually changing, and the United States are clearly showing their way to how we should sample these wildfires. So we can chase these wildfires, we can use weather radars, we can use radio sounds, we can use LiDARs. We have the equipment, the technology, and the knowledge to start actually taking the pulse of these events. Because without taking the pulse of these events, we cannot talk about any understanding and any kind of modeling. Of course, we have some models that work on the assumptions we currently rely on. However, to be able to talk about the next generation of wildfire models that will be able to actually predict when an active wildfire may or may not evolve into a pyroconvective event, for this kind of models, we need more direct measurements.
So, based on the research that you currently have, are you able to determine how how much more frequently pyroconvective events are happening across Europe than they were, say, a year to 5 years ago?
Well, Neil, we cannot really tell, and this is one of the objectives of ROSETTA to try to address this very important question. My intuition is that we are in between two things. On the one hand, due to the social media explosion, it is much easier to have access to video footages or other kind of information that shows you the development of pyroconvection. However, we also know that conditions today are much more conducive to pyroconvection compared to, let's say, 20 years ago. However, we don't really have any quantified measure to say that, for example, we are now getting much more pyroconvective events or not. This is something that we will do in the ROSETTA project. We will make a full catalog of all events, and I hope that this will enable us to have a clear verified understanding of whether we are seeing an increase, a stabilization, or a decrease.
So, looking 10 to 20 years ahead, do you have enough information, enough data at this point to be able to assess what the future of European wildfire behavior will look like and what the projections are?
Yes, this is another thing that we will do in this project, because after we will construct this catalog, we will use what we call atmospheric reanalysis data about the state of the atmosphere in the past, and then we are going to derive thresholds, conditions about that are associated with pyroconvection itself. So in principle, we would like to see how these conditions changed in the past, from the past until today, and then using regional climate projections that tell us how future climate may look like, we are going to see how these conditions may evolve in the future. Intuitively, we expect that in the coming decades, given the rate at which climate change is progressing, we expect to see more conditions that will be more and more conducive to this kind of events. And this is because in a warmer climate, you are going to have much more heat waves that persist over multiple days, much more drier periods, and these are conditions that are defining an environment that will support the organization of pyroconvection should the wildfire ignite in a region with abundant fuels.
Ideally, with your research in mind, how do you see firefighters being able to use the data? And how far in advance do you think they're going to get notice of a pyroconvective event? And do you see them being able to utilize the data during an event as well to be able to make better decisions during extreme fires?
Mhm. Yeah, that's a really good question. I think that on the one hand, when we talk about the state of the atmosphere, how the atmosphere looks in the 3D dimension, both space and time, the first thing is that you can have an early warning several days in advance. For example, for the 2021 wildfires that we had in Greece that were all pyroconvective, going back and studying the conditions that eventually led to their occurrence, we identified that we could have been able to issue a warning about the potential for pyroconvection several days in advance, like, for example, 4 to 5 days before. It was a forecast that could tell that, watch out, the environment is getting very primed to support pyroconvection should we get a wildfire ignition. And then you go to the actual management of the event, which is a real-time process. For this to happen, I believe that you need to focus on having the tools, the data that will allow you to build your tactics real time by analyzing what the fire is actually doing, what are the fire atmosphere interactions you observe, and what do you expect in the very short range, like, for example, 2 or 3 hours or 6 hours ahead. But Whatever the case, whether we talk about an early warning, 5 or 1 week before, or during the event, the very important thing that we need to notice is that we need the collaboration between the two communities, the scientific community and the community of the practitioners. Because in the end, we need to make sure that what I produce as a researcher and what I understand as a researcher can be also understood by the practitioner and can be also applied in the field under pressure and under very high mental load. And this is something that us researchers often neglect. We develop lots of fancy tools, lots of fancy knowledge, but we neglect the fact that in the end, on the field, one human under increased cognitive load will have to make a decision. So work together. This is the final message.
From your research, what is the earliest point that you think you would be able to provide awareness about a potential fire weather event?
Ideally, I would like to see this even at the seasonal or sub-seasonal scale. I know that this is too ambitious. However, I believe that right now, with the tools we have and the knowledge we have now, we can have an estimate of how primed conditions could be for pyroconvection even 1 month ahead. Maybe have a hint or kind of an indication that, for example, we expect in Greece in July, during which conditions could be conducive to the occurrence of pyroconvection. If we increase our understanding and if we manage to identify exactly how the conditions leading to pyroconvection actually work out, then we could also aim for even longer forecast ranges for warning people well in advance.
So, the Rosetta project is currently focused on Europe. Do you have plans to incorporate the North American weather systems as well and other parts of the world?
Probably yes. If we evaluate that the methodology that we're going to apply works out well for Europe, it is the immediate next thing to do to expand these methods to also across other regions of the world. There has been also another very recent effort led by Dave Peterson of the United States, also provided a very detailed catalog of pyro-CB activity, the most intense flavor, let's call it, of pyroconvection. The differentiation of our work is that we are going, because pyro-CB formation in Europe has not been that very common, so we are going to also evaluate, let's call them simple pyroconvective wildfires. However, yes, when we finish with Europe and verify the validity of the results and have a robust methodology, then the next logical step would be to also test the methodology across the States, across Australia, across other parts of the world.
So, when you think about the work that you're doing through the Rosetta project, are there additional tools or technology or partnerships that you feel would accelerate this and get your research kind of to the people that need it the most sooner?
Yeah, the first partnership I could talk about is the one mentioned previously. We certainly need a more close bond between the research community and the community of practitioners, because in the end, what we do, we don't only do it for our scientific curiosity, but we do it in order to provide something that could save a life, that could save infrastructure, that could save the environment itself. So the first partnership that is very important to me is this kind of bonding between the researchers and practitioners. And next, yes, we need also more close cooperation between the researchers themselves. And to be honest, in my experience until now, this isn't the case, at least in Europe. We're seeing still a lot of silos, a lot of research groups doing their own research independently of what is done from other research groups. So this is another thing that we need to break down. Regarding my team, we are very lucky to have collaborations with across the Atlantic. We have a very active collaboration with the San Jose State University and Dr. Craig Clements, who is the global leader in fire meteorology. So this kind of collaboration has taught us that you need to be open, you need to share data, you need to share your methods in order to let research actually advance forward. Otherwise, all alone in our labs, we will develop some kind of knowledge, and at the end, we will try to see how all this knowledge could coalesce in something that the practitioner, the one who needs it most, can really use.
So, what would you say excites you the most about the next phase of the Rosetta project? It seems like there's so much that you're doing and it's all exciting, but what's most exciting to you?
I believe it is what you already asked for, whether we are seeing an increase or a decrease or whatever about pyroconvection. Because right now we are in the middle of the dark. We don't know whether when pyroconvection happened, how it happened. Are we seeing more pyroconvective wildfires? Are we seeing less? Are we seeing the same? And we don't really know. There is knowledge from the United States about the conditions that favor the occurrence of pyroconvection. However, I am pretty much sure that this knowledge should be refined when we talk about Europe due to the different environment, the different topography. So yeah, the most exciting thing is when we finish cataloging these events and have, I don't know how many, I hope a lot in a good sense for our research, cataloging all these events and seeing, okay, we are seeing an increase, we don't see anything, we see a decrease or whatever.
For someone in Europe who's watching this, what expectation would you set in terms of the soonest that they might get a benefit, be able to feel safer, have more awareness about fire weather events that are happening in Europe?
Well, in terms of what we talk right now about the result and its outcome, the project just launched a couple of days ago, actually. I expect that we will be able to have this catalog ready and publicly available to everyone within the next 1.5 or 2 years or so. And I want to think that by the end of 2029, we will know much more about pyroconvection in Europe, much more about what we need to do in order to be better prepared for these events and have an enhanced readiness.
Theodore, it's been a fascinating conversation about fire weather and pyroconvection. Is there anything else you'd like to share that you don't think we've covered so far about this topic?
No, I think we covered it all.
All right, very good. Well, listen, thank you very much for joining me today, and thanks for tuning in to Neal on Fire. If you're passionate about wildfire innovation, smarter mitigation, fire weather, building a safer future, stay connected, follow the show, share an episode, and let us know if you have ideas you'd like us to pursue for future episodes.